Now, in this video, we will going to take up one more problem on projections of lines. How to solve this problem or how to analyze this problem? So here the problem reads as a line capital AB 65 mm long has its end capital A 20 mm above HP and 25 mm in front of VP. The other end capital B 40 mm above HP and 60 mm in front of VP. Draw the projections of capital AB and show its inclination with HP and VP. So he says a line capital AB. So what does it mean? The moment when I say a line capital AB, so that means he has given the true length of the line, which is 65, and he says NDA is 20 mm above HP and 25 mm in front of VP. So he has given the position of the point NA of the line. Similarly, the other end capital B is 40 mm above HP and 60 mm in front of VP. He has given the other end also. That means he has given the locus of A and the locus of B both in the front view as well as in the top view. Draw the projections of capital AB and show its inclination with HP and VP. So that means you have to find, if you want, you can find both the apparent inclinations and also the true inclinations. Now, this is how it will going to look the object in 3 dimensions. So what we can do is first we are going to start plotting the data, whatever it is given. So he says the NDA is 20 mm above HP. You can see the capital NDA is 20 mm above HP. So if you see the capital A is above HP by 20 mm, so when you look from the front view, that image will going to fall on the front view. So therefore, from XY line, you will going to get 20 mm above HP. That image is seen on the vertical plane. So you mark this point as A dash and capital A. Now he says NDA is 25 mm in front of VP. So you can see that the distance from this point to here is the capital A, which is in front of VP. So here you can see the distance. When you look from the top view, that image will going to fall on the horizontal plane. Now similarly, I can see the other end point B. Where is the other end point B? The other end point B is above HP. You can see the distance above HP. That is, this is the 40 mm. So where you can see that above HP distance, when you look from the front view, that image will going to fall on the vertical plane. So this is the distance what we are talking about. The end B is above HP by 40 mm. Now similarly, when you look from the top view, I can see the distance in front of VP, which is the distance that is from here to here, which is 60 mm. Where you can see the distance, that you can see the distance when you look from the top view on the horizontal plane. So that is this, from here to this vertical plane is the distance what we are talking about. That is capital A and B2. And similarly, you have capital A and you have capital B1. So once you get this, so you know the locus of B in the front view and also the locus of B in the top view. And he says since it is the true length of the line, so you have got the fixed point A, but we don't know where exactly that point B1 dash will going to lie on the locus of B. Similarly, the point B2 will going to lie on the locus of B in the top view. Since he says the capital A, so it is the true length. So that means it will be parallel to VP here and this will be parallel to HP here. So if the parallel to HP. So that means if you have the parallel to VP, you know that NDA is 25 mm in front of VP. So obviously the NB1 should also be in front of VP by 25 mm. Then only the line is parallel to VP. Where you can see the distance, I can see the distance when you look from the top view. When you look from the top view, you can see that the distance from here to this capital A is the distance what we are talking about, which is in front of VP by 25 mm. Similarly, when you look from the top view, you can see the distance, which is 25 mm, is in front of VP. So now the line is parallel to VP. Since it is parallel to VP, I can get the true length in VP. What is the length of the true length? The length of the true length is 65. So you know when you look from the front view, the image will going to fall on the vertical plane. So with A dash as center, taking the radius of 65, cut an arc on the locus of B in the front view. So you will go to get this point as B1 dash and capital B. So you have the locus of B, so you mark them. So now the line is parallel to VP. Similarly, you know that the true length is same both in the front view and as well as in the top view. So we have considered the NDA, which is above HP in front of VP by 25 mm, both in the in front of VP in the top view. And what about the point B1? The B1 will going to be above HP by 40 mm. Now, NDA is above HP by 20 mm and also the above HP by 20 mm. Where you can see the distance, I can see the distance from the front view. If you look from the front view, that image will going to fall on the front view. Now, here what happens if you look from the top view? If you look from the front view, I can see the distance above HP by 20 mm and similarly from here also above HP by 20 mm. Now the line is parallel to HP. Once you look from the front view, I can see the distance above HP by 20 and here also I can see the distance above HP by 20. Since the line is parallel to HP, so we are getting the true length in HP. So what is the length of the true length? The length of the true length is 65. You know that the true length is same both in the front view as well as in the top view. So what I can do, if you look from the top view, I can see the distance. I can see that image is going to fall on the horizontal plane. The NDA is here, so you mark that point as small a and you have capital A here. And similarly, since you know the locus of B, why? Because the NB is in front of VP by 60 mm. Since you know the distance in front of VP by 60 mm, so you got the locus of B in the top view. When you look from the top view, that image will going to fall on the horizontal plane. Since you know that it is the true length, so because that is given in the problem with A as center, taking the radius of 65, cut an arc on the locus of B and you mark that point as B2 and capital B and you write locus of B. So then you are going to have the line AB2 in the top view and A dash B1 dash in the front view. So this is the true length in VP and this is the true length in HP. Because true length in VP, because it is parallel to VP. Where you can see the parallel to VP, I can see the parallel to VP in the front view. You can see that the image will going to fall on the vertical plane. Similarly, when you look from the front view, I can see it is parallel to HP. Since it is parallel to HP, I will get the true length in HP. You can see the true length only when you look from the top view. I can see that particular image, which is AB2. So this is how you will be able to analyze this. But how I will be able to represent that on a two-dimensional drawing? So when you rotate, the vertical plane is fixed, so VP will be above XY line. Since HP is rotated down, so HP will going to become below the XY line. So once you rotate the HP, what happens? The image, whatever you have, small AB2, will going to come below XY line. So you draw the XY line and you mark XY and VP HP. Then from the XY line you measure 20 mm and draw a horizontal line. Similarly, from XY line you measure 25 mm in front of VP. In front of VP is seen in HP. So you draw one more horizontal line parallel to xy in the top view. Then you take any point from here, you draw a vertical projector which will going to cut both the parallel lines drawn previously. And you mark this point as A dash, and you mark this point as capital A, and you mark this point as A, and you mark this point as capital A. Again, from xy line, you measure 40 mm. Now what I am doing is, I am taking this above HP now. So this distance, when you look from the front view, it can be seen in the vertical plane. So from xy line, you measure 40 mm, you draw a horizontal dash dot line, and you mark that as locus of B. Similarly, from xy line, you measure 60 mm below xy line, you draw a horizontal dash dot projector, horizontal dash dot line parallel to xy. Then you mark that point as, you mark that as the locus of B in the top view. Now, you know the locus of B in the front view and locus of B in the top view. What exactly the meaning of locus of B? So that means the other end point of the line of the true length and also the front view will going to lie on the locus of B in the front view. And similarly, B2 and small b are the endpoints of the true length and the top view line will going to lie on that locus of B. So as we know that true length is same both in the front view and as well as in the top view, with A dash as center, taking the radius of 65, cut an arc on the locus of B in the front view by using the compass. Similarly, with A as center, taking the same radius of 65, cut an arc on the locus of B in the top view. And you mark this point as B1 dash and you mark this point as B2. And since it is the true length, you mark that as capital B and you mark this as capital B. Join A dash B1 dash and similarly you join between A, B2. So this is how you will be able to write the whatever the actual data given is transferred into the orthometric view. Now in the next case what we need to do is I need to project. How to project? So we have this line, right now we have this line and we have this line. So if you look from the front view, this line will going to fall on the vertical plane, and when you look from the top view, this line capital AB2 will going to lie on the horizontal plane, which is small ab2. Now I want to project this to get the, so we know that this line is the true length in the front view and this line is the true length in the top view. That is A dash B1 dash is the true length line in the front view and small ab2 is the true length line in the top view. You know that this is the true length in VP. So this is the front view line. How do I know that it is the true length in the vertical plane? That is because both A and capital B1 both are in front of VP by 25 mm. Since it is in front of VP by 25 mm, both capital A and capital B1 are in front of VP by 25 mm. Therefore, the line is parallel to VP. Since the line is parallel to VP, I am getting the true length in VP. Now, since I am looking from the top view to decide that this is the true length line, so obviously I have to look from the top view to get the top view of this, because we don't have the top view for A dash B1 dash. Since we don't have the top view for A dash B1 dash, I need to find the top view now. So therefore, I am looking from top view. When you look from the top view, I can see the distance in front of VP by 25 mm in both A and B1. So therefore, I am projecting that point from here to here. You got small a, but you have small a, but we don't have B1. So you're drawing a vertical projector from capital B1, which is in space, till to the locus of A in the top view. So now both small a and small b1 both are in front of VP by 25 mm. Since the line is parallel to xy in the top view, obviously in the front view that line will be in true length. So this is how you will be able to analyze this. Now similarly, I want to find the front view of this line. Why? Because when you look from the top view, this image will going to fall on the horizontal plane. So the line is, this line is the true length in HP. What does it mean, the true length in HP? This line is parallel to HP. Where you can see that parallel to HP, when you look from the front view, both capital A and capital B2, both are above HP by 20 mm. So now the line is parallel to HP. Since the line is parallel to HP, you are getting the true length in HP. So in the top view, you know that it is small a and small b2. So it is capital A and capital B. Now this is the true length line. How do I decide that it is the true length line? When you look from the front view, I can see the distance above HP by 20 mm, and I can also see the distance B2 is above HP by 20 mm. So both these 2 points are above HP by 20 mm. So where you can see that? You can see that in the front view by looking from the front view. Therefore, you have the top view line AB2, but do you have the front view line of A dash B2 dash? No. So now I need to find out. When you look from the front view, I can see where that image will go to fall. The point capital A's image is falling in this on A dash line, which is already marked. But since this is the true length in the horizontal plane, that means both A dash and B2 dash should be above HP by 20 mm only. Now the line is parallel to HP. So obviously, I have to draw a projector from capital B2 to the locus of A in the front view. So because A dash is above HP by 20 mm, so B2 dash should also be above HP by 20 mm, then only the line is parallel to XY line in the front view. Since the line is parallel to XY line in the front view, obviously in the top view, that line will going to be in the true length. So this is how you will be able to analyze how to write the top view for the front view true length line, and similarly front view for the top view true length line. Once you do that, that is what we will going to write here. Previously we have drawn till this locus of B in the this true length line in the front view and this true length line in the top view. So you know that this is the true length in the front view. That means this line should be parallel to XY in the top view. How I can get that? NDA is in front of EB by 25 mm. Similarly, the NB also should be in front of EB by 25 mm. Then only the line becomes parallel to XY, which is that line what we are talking about from this 3D point is AB1. When you look from the top view, both capital A and capital B1 are in front of EB by 25 mm. That is what we have. A and B1 both are in front of AB by 25 mm. That's what I have shown here. From B1 dash I had drawn a vertical projector till to the locus of A in the top view. So both A and B1 are parallel to XY in the top view. Obviously, you are going to get the true length in the front view. Similarly, you know that this is the true length in the HP. So that means it is parallel to HP. So NDA is 20 mm above HP. The NB2 should also be above HP by 20 mm. Therefore, you draw a vertical projector from B2 till to the locus of A in the front view. So both A dash and B2 dash are above HP by 20 mm. That is what this line, what I am referring to. When you look from the front view, NDA is 20 mm above HP, NB2 is also above HP by 20 mm. Then only the line is parallel to XY in the front view. Since the line is parallel to XY in the front view, obviously that line will be in true length in top view. So this is how you will be able to analyze it. Now I need to find the top view and front view. So how to do that? So what I am doing is, so I have the line in space which is capital AB1. With A center taking the radius of AB1, I will going to rotate this point B1 like this. When you try to locate the point B1, now the B1 is in front of VP by 25 mm. But actually, due to the presence of this line, so that means that B2 is in front of VP by 60 mm. So obviously that image which was B1 here, I want that image to lie on the locus of B in the top view. So how to rotate it? How to rotate that? With A as center, taking the radius of AB1, then start rotating that point B1. Originally it was in front of VP by 25 mm till it reaches 60 mm in front of VP. So when you are doing it in space, what happens to the image? So since you are looking in the top view with A as center, taking the radius of AB1, you are rotating in space. Obviously, that when you look from the top view, that image which is AB1, which is here, that B1 is in front of VP by 25 mm, is rotated such that till that B1 will going to come and cut on the locus of B in the top view. So now you got this point small b. So you join A to B with a dot line. So this will going to be the beta inclination line, and the true inclination with respect to VP is phi, and the apparent inclination with respect to VP is beta. Now we have got this. Now we will show that here. So originally the B1 is in front of VP by 25 mm. Since you have the locus of B in the top view is at 60 mm from the XY line, with A center, by taking the radius of AB1 by using the compass, you rotate it such that B1 will going to lie on the locus of B in the top view. That means instead of having B1 in front of VP by 25 mm, that it will be in front of VP by 60 mm. So that the length of this line AB1 should not alter. So that is possible only by holding the point A with the radius of AB1 you are rotating, so that it will going to come and touches the locus of B in the top view, and you mark B and join A to B with a dot line. So this is actually the top view line, which is that is what we have shown here. So when you are rotating in space, what happens? The image in the top view also is being rotated, so that B1 which is in front of VP by 25 mm will become the in front of VP by 60. The radius of AB1 is same as the radius of AB, such that the length of the line should not alter. So this is how I will be able to get the top view. Now I want to get the front view. So how to get the front view? So in the front view, what is the distance? NDA is above HP by 20 mm and NB2 is also above HP by 20 mm. Therefore, the line is parallel to HP. Since the line is parallel to HP, so you are getting the true length in HP. So that is AB2. Now what I am trying to do now? I am trying to rotate this B2 dash, which is here, will come to the locus of B in the front view. What is the locus of B in the front view? The locus of B in the front view is 40 mm. So instead of B having above HP by 20 mm, it should become B above HP by 40 mm, such that the length of this line, that is A dash B2 dash, should not alter. That is possible only by rotating with reference to A dash. So if you have right now the point AB2 is above HP by 20 mm, but actually what he is telling, the B is not above HP by 20 mm, but it is above HP by 40 mm. So with A center, taking the line as AB2 as the radius, you are rotating in space, such that originally the B2 was above HP by 20 mm, will going to become above HP by 40 mm. Till that distance, I want to rotate this line in space. By doing so, what happens? When you look from the front view, the image which is A dash B2 dash is being rotated such that B dash is above HP by 40 mm. You are rotating till that B2 dash will going to become above HP by 40 mm, such that the length of A dash B2 dash is same as the length of A dash B dash. So till to the locus of B in the front view. So you mark this point as B dash and join A dash B dash with a dot line. Now this will going to be the angle which is alpha, and this angle is going to become beta. Now, once you join, so we have B to B dash and we have B to small b. So this is actually the image what we are getting. But when you look from the front view, you can see that this is the line what I am talking about. When you look from the top view, you have this line which is capital B to B dash, that is the distance. When you look from the top view, that image will going to fall here. Okay? When it is being rotated, both B dash and B will going to lie on the same line. So this is how I will be able to, if you check that line, it will be exactly at 90 degrees. That is how we will be able to say that your drawing is right. Now when you come to this, you can see we have A dash B2 dash which is above HP by 20 mm. But what I want B2 dash which is above HP by 40 mm. That means the locus of B is not above HP by 20 mm. Instead, the locus of B is above HP by 40 mm. Therefore, with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B in the front view. And you mark this point as B dash and join A dash B dash with a dark line. Okay? And then show the directions of projections. So then you mark this angle as alpha, and you mark this angle as theta, and you mark this angle as phi, and you mark this angle as beta. So theta and phi are the true inclination with respect to both HP and VP, and similarly alpha and beta are the true apparent inclination of a line with respect to HP and also with respect to VP. Then since we want to find out the true and apparent inclination by using the protractor with A dash as center, with reference to the horizontal, you measure the angle theta, which is 18 degree. So you have given 17.92 when you are doing it in CAD, but when you are doing it in manual, it will become 18 degrees, and then alpha will going to become 21 or 22 degrees. And similarly, by using the protractor with A as center with reference to this horizontal line, you measure angle phi, which is the true inclination with respect to VP, which is 33 degrees. But actually when you are doing it in computer, it will be 32.58. And then with A as center with reference to the horizontal, you measure an angle of beta, which is equal to 35 degrees or 34 degrees. You have 34.47, that is the apparent inclination with respect to VP. So how do I know that my problem is right? You know that this is the front view because the top view line AB is inclined. Similarly, you know that this is the top view AB because the front view line A dash B dash is inclined. So in the apparent inclination views, both the front view and top view will always be inclined to both HP and P. Similarly, you know this is the true length in the front view because the top view line is parallel to XY. You know this is the top view true length because the front view line is parallel to XY. So when you are joined between both B and B dash, both will going to lie on the same line. So this is how you will be able to analyze, and this is how I will be able to tell that my drawing is right. Thank you.